Okay, this is our last video on parametric and vectors. This is just kind of the same stuff that we talked about in the introduction, but we're just going to do some application problems. This one will need you to use the calculator. The whole entire assignment does. So if you don't have your calculator out, because you are definitely going to want to practice doing these things on the calculator. So if you don't have your calculator, pause the video and get your calculator. This is the exact kind of stuff that if it's on the AP exam and it's a calculator question, you don't want to be fumbling around trying to figure out how to use your calculator to answer the questions. You definitely want to have practiced and know what you're doing. So the more practice before the test, the better. So we are going to talk about displacement and the distance traveled with your vectors. So say that we have a velocity vector. So remember that our velocity vectors are just simply made up of the components of x and y. And so they're just the derivatives of the x and y components of the position vector. And remember, you don't have to have chevrons around it. It can be parentheses or it can be chevrons. So you have to know, okay, they're talking about a vector. And so it doesn't matter if it's parentheses or not. That's how you know it's a vector. The displacement from time A to B, assuming it's time here, it should be if it's velocity, but you're going to have the vector. You're simply going to integrate, which you already know that you would do. You would integrate the velocity in order to get the displacement. Well, all you're doing is integrating each part separately. So it's not really anything new. This will just give you more practice. It's just that we do each part separately because there's an x and y part separately, but that part we already know. If you want the current position that you're at this moment, moving from time A to time B, then you simply add that vector to the position that you had at time A. So in other words, where you started, you had a position. So maybe you were at 3, 4, the point, the vector was 3, 4. So then whatever this vector is, you add it to that, and that'll give you your position at time B. So no absolute value gives you displacement. If you want the distance traveled, the actual distance traveled, then we want the arc length. And so we're going to find the integral from A to B, and then it's basically, remember, your Pythagorean theorem. So square root of x prime squared plus y prime squared, and integrate that. So there's your displacement and distance. So we're going to do some problems with that. And again, these are calculator problems. So I'm going to show you on the calculator a few things just in case to make sure that we know what we're doing on that. Now, if it wasn't a calculator problem, you would just do them by hand, and then probably they come out a little bit nicer. These obviously are things that are not going to come out that nice. Now, if this was an open-ended question, a free response question asking you this, then you would want to be sure you're showing what you're doing. So they want us to find the acceleration vector. So very simple. All I have to do, it says the acceleration vector at time 2. So I just write acceleration vector at 2 is going to equal, we don't have velocity here, we have, well, we kind of do, but we're given the position vector as x, t, y, t, so we'll just write x double prime of t, comma, y double prime of t. That's your acceleration vector. Oh, and instead of t, I guess I went ahead and wrote 2, so we just write at 2. And that's it. That's the work I need to show. Rest of this is in the calculator, okay? So let's learn and make sure we know how to do that in the calculator in a couple of different ways so that you can choose what is easy for you. So they've given me dx dt and dy dt. So I just need to find the derivative one more time, each component separately, plug 2 in. So on the calculator, then what we can do is we would want to let it do the derivative and plug the number in without me doing a whole bunch of work. Now there's a couple of ways to do this. So I'm going to show you one way to do it, and then I'll show you another way to do it for, I'll do it one way for the x vector and a different way for the y vector. So on a calculator page, because this is a calculator type thing, we are doing something in calculus. So go to menu and go to calculus. and you will see that they have something that says derivative at a point. So that means that I want to, there's derivative and there's derivative at a point. Well, I'm trying to do this derivative at a point, so it would make sense to choose that. So let's choose derivative at a point. It's going to ask you the variable that you're using. You can use x, you can use t, you can use whatever you want. I usually just stick with x and use x all the time, but you can do t if you want. It doesn't matter there. So I'm just going to leave it x, and then the value is 2. I'm trying to take the derivative at 2, and I only want the first derivative here because they gave me the first derivative. They gave me dx dt and dy dt, and I just need one more derivative. So I just want it to take the derivative once. So I tab down to OK, or you can just press enter. And then what pops up is the template. So the template for the derivative, and I'll show you how to do that in the shortcuts in just a second. And then you have the vertical line, which means evaluated at, and then x equals 2. So we can also just type that in ourselves, and I'll show you that on the next one. So first let's start with dx dt. Now I'm going to just use x instead of t because I just think it's easier. I just use x, but you can use t too. So I'm going to put x, and then remember to just get in the habit of kind of putting the times sign in because of the, sometimes you need that to put that there. So I would just go ahead and put times, and then sign. So go to your trig menu and get sign of x, and then press enter. And it's going to give you the answer. Well, I don't want that answer probably. It's a calculator problem, so probably I want the decimal, so I want to do control enter, or at any point you could have put, like, you could have said evaluate at 2.2 point, and it would have done that, but just do control enter. So far I have 0.077. That's for the x. All right, so let's do the y, where we go ahead and get that template kind of started ourselves, and it's not very difficult at all. So remember that shift plus sign gives me the quick integral. Well, shift minus sign gives me the little derivative template. Now this time let's use t. Doesn't matter. I'm just going to use t. So I'll put t there. Could have used t in the last one. And then I'm going to put in my dy dt that I need to take the derivative of, and it's cosine of t squared. So cosine, and use t this time, cosine of t squared. Now instead of just stopping there, I want to put in that vertical bar and evaluate it when t equals 2. The vertical bar, the evaluate at, is on the equal sign. So you do control of the equal sign, and you can see it there if you look carefully above the equal sign. You'll see the little vertical bar in the little blue parts, and just go over and select the vertical bar and then say t equals 2. And if I put 2 point, then I should get the decimal right away, and there we go. And so that's another way to do it. So you can either use the little template and go through the little wizard like we just did, or you can just do that yourself. So either way, and here's the answer. And I'm finished. So very simple to find the acceleration. It's just a second derivative, no different than before. So again, none of this stuff is really very new. It's just a little different in how it's worded. So perfect time to do this right before the test. It kind of reviews some of those things for us. Also, okay, so now we want to write the equation of the tangent line. Well, what do we need to write an equation of a line? Well, we need the slope and we need a point. So let's go and look and see that they have given us a point. They told us at time t equals 2, because we want the tangent line at time t equals 2. Well, they told us the point is 1, 4. So I know the point, so the only thing left for me to do is find the slope. Well, the slope is dy dx. That has not ever changed. It's still the same thing. Dy dx, well, dy dx is actually very simple, because I'm going to go ahead and write down what it is, but then I'm going to go ahead and show you, we could just do this in the calculator, but remember the formula for dy dx is just dy dt, which they've already done for me, over dx dt. And so really I could just plug 2 in, and there we go. So it may not be any quicker to go through the formula to do all of that, because actually this might be even faster. All I do is do dy dt at 2. So if I want to evaluate this when t is 2, I'm just going to simply get cosine of 4 over 2 sine 2. Now, if this is a free response question, you can leave that. You don't even have to get a decimal for that if you don't want to. As long as your answer is numeric, you do not have to simplify that. So you can leave that. So we could just write the equation, y minus the y value, which is 4, equals the slope we just found, cosine 4 over 2 sine 2 times x minus 1. And we're done. And you can leave it that way. The only time, again, that you would worry about needing to get the decimal approximations and all that is if you were trying to match it on a multiple choice. But if this is open-ended, leave it. You're finished. It's a correct answer. The numerical parts are, this is numerical, so that's the answer, and there you go. Okay? So don't overdo it on simplifying. Okay, C, I think, was actually back there. That was on the next page. Now we want to find the speed of the vector at time t equals 2. And actually, it's not vector, it should say object. So let's change that. So we want the speed of the object at time t equals 2. Well, remember, speed just means absolute value, norm, whatever you want to call it. We want that at 2. So double bars for magnitude or speed of the velocity vector. So again, on a calculator problem, if this was open-ended, I would just want to show my process here. So all I want to do is do x prime at 2 squared plus y prime at 2 squared dt. And then from here, I would just do the calculator to do this. Now, this is actually pretty simple to write out because they already did x prime and y prime for me. So x prime was t sine t, so at 2 would be 2 sine 2, and then we want that squared, plus y prime was cosine of t squared, so this is cosine of 4 squared. Oh, and I didn't mean to write dt. I'm thinking of integrating. We're not integrating this. We're just finding that, and that's it. And so there you go. There's the answer. If you are, maybe it's a multiple choice question and not a free response question, then you'd want to go ahead and find the decimal. So the decimal is 1.932. Now remember, if this was a free response question and you somehow needed to use this value later, you can store that. And we've gone over how to store that in your calculator. So you would store that as some letter, call it, V for velocity, or A or B because it's the first one or second one or whatever you want to call it, so that you could then use that if you needed to later. All right, so let's go to part D for this problem. Part D says find the displacement of the particle from t equals 2 to 7. Well, the displacement of x is going to be to integrate displacing from 2 to 7 of x prime of t dt. That's how you find displacement. Well, again, calculator problem. That's not something that we're going to do by hand. We're going to do that in the calculator. So in the calculator, remember that we have a shortcut again to do integration, which is, or not control, sorry, but shift plus sign gives you the integral sign. Whoops, I guess I needed to be on the other side of that. Yeah, I'm not lined up very well here. Okay, so shift plus sign gives me the integral template. I want to go from 2 to, well, if I can get there, 2 to 7 of x prime, and x prime was x sine x or t sine t. It doesn't matter as long as you put the same thing. So we'll do t sine t. So t times sine t. Oh, and I don't mean to have, well, it doesn't matter. I have caps on there on accident, but that doesn't matter as long as I make this one capital T also. And then hit enter, and you'll get your answer. And of course, we don't probably want that. We probably want the decimal. And so we get that it is negative 6.361. And so we can just, again, just use the calculator for those. So displacement of y is the integral from 2 to 7 of y prime of t dt. Again, just do that in the calculator, and you get 0.096. If they ask me to say the position of the particle now at time 7, then I would simply add those two numbers to the original position of the particle, which was at 1, 4. So I would take 1 and add negative 6.361. That would be the new x coordinate. And I would take 4 and add 0.096, and that would be the new y coordinate. So that would be the current position. But they just asked me for displacement, so I'm done. Then it says find the distance traveled. Well, to find the distance traveled of the particle from time 2 to 7, that is the equivalent to the arc length. So I want to do the arc length from 2 to 7. I want to figure out how far did it travel along this curve. So how far did it travel on the arc? And that's just x prime t squared plus y prime t squared, square root of all that, dt. And again, very much just a simple formula. You're using, it's like using the Pythagorean theorem. So again, just simply do that in your calculator, 13.229. So good suggestion to pause these, type them in the calculator, and double check them, or at least go back and do them yourself when you're done to make sure you do know how to do it in the calculator. All right, then this last question says, let's find, a last part of this question says, find the position of the particle at time t equals 1. Now remember, they gave us the position at time t equals 2, and they told us it was at 1, 4. So we're kind of going back in time here. We want to know, where was it when the time was 1? So that means we want to find, and you can write it with chevrons or not, I want to find the position x1, y1, because I want to find the x and y coordinates at time 1. So that's going to equal 1 plus, so that is your current position at time 2, because that's the known place, that's 1, plus the integral from the current position to the new position, which would be 2 to 1 of x prime of t dt, comma, current position at time 2, which is 4, plus integral from current position to new position, y prime t dt. And so again, calculator problem, type all that in the calculator, and you should get negative 0.440, comma 4.443. And it doesn't matter if you use chevrons or parentheses. We know it's a vector because it's talking about vectors and so on. So you can use either one. So that would be your position. So again, check that. That's saying before we got to 1, 4, at time t1, we were here, and then we moved in 1 second up to the position 1, 4. All right, so let's do the next example, example 2. So now, again, we're moving on a curve. This time, the only thing we know is dx dt. We do not know dy dt explicitly, and we do know a position as 3, 5 when time is 2. So they want us first to find the x coordinate of the position at time t equals 4. Well, we have dx dt, so if we want to find the x position at time 4, then we would want to take the current position plus the integral from where it was, which was at 2 seconds, to 4 seconds of x prime t dt. So let me point to each of those things so you can see where they come from. So they told us that we wanted to take, that we knew at time t equals 2, okay, we knew the position was 3, so that's this current position for the x coordinate, and we want to know what's happening at time 4. So we have to go from 2 to 4, because 2 is where we're at currently, so we've got to move ourselves from 2 to 4. And then we do this again, just do this in the calculator, because they give you dx dt right here. So all you have to do is do 3 plus, do shift plus sign to get your integral sign, fill everything in, use that formula, and you get your answer, and your new x position is 2.885. So this is telling me this is the x coordinate of my object at time t equals 4. So it's moved to there from time t is 2. All right, so next question says at time t equals 2, we know that dy dt equals -6, the value of it. So we don't know dy dt still, but we know that if you were to plug in 2, you would get -6. We want to write an equation for the line tangent to the curve at the point x2, y2. So in other words, at time t equals 2. Well, what do we need to do to write an equation of a line? Well, we need the slope and we need a point. Well, we know the point because they told us what x2, y2 is. It's 3, 5. That's the position we're at time 2. So we know the point, and we know that y prime of 2 is -6. So we just have to find dy dx, but we know parts of what we need. Okay, so let's go ahead and find dy dx here. So we know that dy dx is found by taking y prime at t divided by x prime at t. Well, we don't know dy dx or dy dt, so what we really need to do though anyway is we want to know what's the value of dy dx at t equals 2. So we want to know, okay, if we're evaluating it at 2, what do we get? Well, that's going to be y prime at 2 divided by x prime at 2. Well, y prime at 2 is very simple. It was given. It's -6. X prime at 2, all we have to do is look at the original problem up here, and it says that dx dt is 2 sine t squared. So dx dt at 2 is 2 sine of 4. And that's going to be my slope. So to write my equation, again, unless you're told specifically you need to simplify it or you're trying to match it, leave things pretty much the way they are. So our equation for a line is y minus the y value, which was 5, equals this slope that we just found, so just leave it, times x minus the x value. And then again, if it was matching something, it was multiple choice, then you might have to change your slope to a decimal and move stuff around. But if we don't need to, don't do it. All right, so next part of the problem, part C, find the magnitude of the velocity vector at time 2. So we want to find what is the magnitude of the velocity at 2. So that just means square root of x prime at 2 squared plus y prime at 2 squared. Well, x prime at 2 is, again, they gave me x prime of t. They told me it was 2 sine t squared, so 2 sine of 4. I need that whole thing squared plus y prime at 2. Well, I don't know y prime, but I know y prime at 2 is -6. So that's -6 squared. And then again, leave it. Unless it's multiple choice and you need to match, and if you do, then you got to put it in the calculator. Use the calculator properly though. Go to a calculator page, start with the square root, put everything in there, parentheses and all, exactly as it's written so you don't make a mistake. Because the last thing we want is to miss a problem because we didn't type it in the calculator right. Okay, so last problem for this video, last part of this problem and last end of the video. Now they're telling us that when t is greater than or equal to 3, that we have an equation right here for the tangent line. Okay, or the line tangent has this slope. So when t is 3 or more, this is the equation for the slope of the tangent line. We want to find the acceleration vector of the object. Well, the reason we need to know that information is, so here's what I would do to start this problem. I would say to myself, okay, what they're asking me for is, what is the acceleration vector at 4? Well, to find the acceleration vector means I need to find the second derivative of the position vector at 4, second of each component, so of the x and the y. Okay, so I need to find the second derivatives there. Well, x is easy to find the second derivative because I was given the problem, the value, but y is not so easy. So over here to the side, let's do some work here, or actually let's just go ahead and I may move this over to the side, and we'll go ahead, and that's where I'm heading. So over here, let's do our derivative. So we know x prime of t, that was given to us. We were told it was 2 sine of t squared. That's given at the beginning of the problem. So the second derivative is super easy. I need to go through this process. So derivative of sine is cosine. So we know we'll get cosine of t squared times the derivative of the inside, which is 2t. And there was already a 2 out front, so that makes 4t. So my derivative is 4t cosine t squared. So x double prime's handled. That's easy. So now let's figure out how we're going to get y double prime. Well, we know that dy dx is 2t minus 1. That was given. I boxed that in. They told us, here's the slope of the tangent lines. It's 2t minus 1. Well, I know that the way I find that answer is to take y prime at t over x prime at t. Well, I know x prime at t, so that will allow me to solve for y prime at t. So here's my equation, 2t minus 1 equals y prime at t over, well, x prime was again given. It's 2 sine of t squared. So I know that value, and now to solve for y prime, I just multiply. So 2t minus 1 in parentheses, 2 sine t squared, that's going to be y prime at t. So in order to find the second derivative, I just need to take the derivative of that derivative. And I don't need to do that by hand because I've got the formula there. So again, calculator problem. So you go through and check this and make sure you get the right answers. Negative 15.322 and negative 108.408. So you will then need to go through, we know x double prime of t, we will need to find the derivative. You'll have to find this derivative evaluated at 4. So again, do that in the calculator, double check your answers are right, and there you go. Really pretty simple. Most of these problems will be calculator problems like this, or they'll be super simple numerically anyway. So you just need to know the process. So that is it for parametrics and vectors. And now we know what we need to for the AP test.